Okay, here's our video on bivariate data and scatter plots. So bivariate, we can break the word down. The bi means two, so you're dealing with two variables, the x and the y. So bivariate just means that we're observing the measures of two variables. So for example, let's use a scatter plot where we're talking about the value of a car's age. So here they have the value. We'll put the value here. This is the y, the value. And the x will have as the age. So there is a correlation between the age of a car and how much it cost, how much it retained its value. For example, when you buy a new car, it makes sense that the car would be more expensive than if you bought a used car. So as the car ages, the value of the car goes down. So here we have a correlation. We have a negative correlation because it's going down. And you can see there's a relationship between the x and the y. So this is bivariate data because we're measuring, observing two variables. Now we can do another one with the scatter plots. We can do ice cream sales, the temperature. Now, as the temperature goes up, the ice cream sales go up also. So this could be the temperature, x could be the temperature, and y could be the sales. And of course that makes sense. Most people don't buy ice cream when it's 0 below. Even though you could buy ice cream when it's winter time, the sales in the summer increase. So in this case we have a positive correlation because it's going up. So we have a couple of types of scatter plots we'll deal with. Positive correlation, negative correlation, and when there's no correlation, when it just looks like it's just random dots everywhere, then there's no correlation. Now when we deal with scatter plots, we can have clusters and outliers. An outlier is someone who's not part of the mix, like that F. Or maybe this G. They're just not part of the cluster. And the cluster is just basically what it says, a cluster of items very close together. Also, univariate data. That's when you only have one variable. And that's if you just, like for example, you want to know the weight of the puppies. We just have the weight of the puppies. We have nothing else. When you come across something like that, it's univariate. But most of the time, we'll be dealing with bivariate. Now, when we have a scatter plot, we want to plot the line of best fit. And that's where we're estimating, basically, where most of the data is fitting. So here's a line of best fit. And we know that this line is going down, so it's negative. This is a negative correlation. We want to draw the line where the data is just as much as below the line as above it. And that's where we get a line of best fit. Now here's another example. In this case, it's a positive correlation. And the blue line is the line of best fit. Sometimes it's hard to see the line of best fit. Here it looks like we have a giant cluster. And it looks random. But as you can see, some of it is moving up. As the income increases, the health index seems to go up. So this could be a positive correlation. However, it's very close to being no correlation. Because you do see some people who make less money have a high health index. Okay, what kind of correlation is this? Well, as you can see, the data seems to be going up, so it's a positive correlation. This is the line of best fit. Now, sometimes you'll be asked to make an estimation of an equation, of a linear equation. So you just make the line of best fit, and then make the equation. So we can see that it crosses at the 2. So we know automatically then we have our linear equation, y equals mx plus b. we know it's y equals mx plus 2 so far, because it's going through the 2. Now we need to find the slope. Okay, so when we want to find the slope, we can pick any 2 points on the grid. So we have a 1 and we have a 3, or we can use a 0 and 2. And we can also use a 3. Looks like a 3 goes up to 5. So whatever ones you want to use, and you can use negative ones also. So again, we have 0 and a 2. That's a pair. And the 1 and 3 are pairs. Or we can just say 3 and 5. Right. Now what do we do from there? So we have our change, and we use the delta sign, the Greek letter delta, the change in y over the change in x. That's what we're trying to find out, the change in y over the change of x. And that's basically, we're doing 3 minus 2 and 1 minus 0. So the change in y is 1, and the change of x is 1, so the slope is just 1. Again, the change of y over the change in x is just what we did in class, y2 minus y1 over x2 minus x1. It's the same thing. So now that we know the slope is 1, we have y equals 1x, or you can just put an x, you don't have to put the 1. And we know the y-intercept is 2, so here's our equation. Y equals x plus 2. So just remember some key words now. That's bivariate, and that's when we deal with 2 variables, x and y. If you're only dealing with 1 variable, it's univariate. Okay, and one final thing for this video. When we're looking at the line of best fit, and we want to make an equation for it, when you make your equation, when you make your line, your straight line, here you can see that the line is getting close to 5. So you want to just get an equation that's close to your line of best fit. So as you can see, the line here, you might not see that number 5 in the video, but it's very close to what 5 is. So we know automatically that when we're doing an equation, y equals mx plus b, we can write y equals mx plus 5. But it's important to know that this is going to be a negative slope because it's going down. It's a negative correlation. So we also know that this will be y equals negative mx plus b. So just be careful when you're making an equation based on a line of best fit.